He's a program manager in the Microsoft Surface Group, most recently working as a program manager on the mechanical aspects of the Surface 2 or the Surface Studio. He began his career in mechanical design on the Surface 2 and 3 before transitioning into program management. Prior to working at Microsoft, he grew up on a farm in South Dakota and then spent his high school and college years in Oregon before moving to Seattle for his graduate schooling at the University of Washington. In his free time, he likes to rock climb and do as much mountaineering as possible, and he's here to explain some of the Microsoft Surface technology. Welcome, Matt Fiedler.
When people have thought about Microsoft in the past, typically they think of software, obviously, Microsoft. But now we're starting to do a lot of hardware as well. So I started there 5 years ago, and at that point we had very few people working on hardware. We hadn't released a Surface product yet, and now we've grown tremendously. So I'll tell you a little bit about that. And also, I know some of you are kind of trying to figure out what it is you want to do exactly and what it is, what the different industries are you can work in. So I want to go do some deep dives on some of the technical challenges that we face here and what individual engineers are actually working on, so you can get an idea of like, oh, is this something I actually want to do or not? Why is Microsoft even doing this? What's the point of hardware here? Now, first of all, the reason that Microsoft has even embarked on this is we want Microsoft software to be beautiful, and we want people to see that. And it's great to be able to buy a product that for $300 it's really inexpensive, but to really show off the beauty of what it is that you can create and what you can do. These are the products that really show people what it can be. So along the way, then, what do we want to do? Like, how do you do that well? And our whole goal is that you make the hardware so it disappears into the background, so that you fully experience whatever it is you're creating. So let's not make it about our hardware. Let's make it about you and what you want to do with your product. And you can see as you look at this at the product, and there's one over here. Our whole vision the whole time as we're going through this is making a floating sheet of pixels. So floating being that, if you look at this, it's incredibly thin. So you almost don't even notice that you have anything up there other than pixels. And also when you're looking at it, this base is as small as we could possibly get it, so you don't even notice the hardware there. And these chrome hinge arms are as thin as they can be, and they reflect the surroundings so that when you look at it, it's almost hard to tell that there's something holding it up. So I'm going to go into a few details about what that actually took to do that. All right, so let's just start from the ground up. So at the base here, it doesn't look like there's much, but there has to be a ton that goes into that. And I don't need to read off a big spec sheet to you guys because you can probably read better than I can anyway. But there's a CPU in there, there's a GPU, there's a hard drive, which has there's SSD as well. Then we also have all the connectors that we have in the back there. Because although we want it to be beautiful, we don't want our beauty to get in the way of you being able to have a fully functional PC that's high performing, that has all the ports you want, that has everything you need. Now, in addition here, there's also speakers in there. We put our PSU inside the box so that when you buy the product, it's just one cord that you have to plug in. Now, what all of that has done, and by trying to make that as small as it can, and this is where we get into, these are the technical problems where we really have to dive in and do difficult engineering work. So you have three important things to notice here. You have a PSU, a GPU, and a CPU. And the thing that all three of those really have in common is that they produce a ton of heat. And if you know anything about thermal management, the best way to manage thermals is to get in a ton of coolant of some kind. Typically, we end up using air. Some people end up doing water cooling. In this case, what we have to do when you're putting air in, you want as much space as possible, which puts us in direct conflict with our vision of it being as small as possible. So the other thing to note here is there's another item you see there. It's a hard drive. Now, I don't know, have any of you guys had a hard drive fail in the past? Yes, super common thing to have happen. Now, what not everyone knows is if you look at a failure rate graph of a temperature versus failure rate, as the temperature increases, the failure rate projections on hard drives go up incredibly. And at one point where we were with how hot it was inside that box, we would have had a 10% failure rate, which if you're in the business of trying to market a product to somebody, you don't say, oh, hey, look at this device. This is great. You're going to buy it, but there is a 1 in 10 chance that this thing is going to lose all of your data. That's not a way to sell a good product. So what we had to do is really go in depth here and say, how can we solve this problem? So the first thing that happened is we said, we need to get more air in there and still have it be beautiful. And if you look over here, you guys can come look later, there's a vent that was added up on the top, which we didn't want to add, but had to add in order to get the airflow in there. So it's air being sucked in up top. And now on the bottom, if you also come look later, you'll see right in here, there are vents in that area as well that you can't see as well. So there's air going in there as well. Try to get as much flow as possible. Now, if you're sitting there, you also don't want hot air coming back at you. So you can see this is the direction of where the user sits. So there's only air coming in there, and the air is going out the sides and out the back. So there are a few fans here. There's a GPU fan, CPU fan, and PSU fan. So all of those are running harmoniously, and in the process of doing that, there are a bunch of other complications too. You don't want the fans to be too loud. You don't want it to be running at a super high RPM all the time. But you also, like I said, you don't want to compromise the performance of your device or to compromise the failure rate that you have. So just through doing this, you made a ton of progress. Now, at that point, you could say, all right, we're pretty good, but we're not quite good enough. So what do you do next to improve it even further? So what we did is there's a thermal module in here, which was needed anyway in order to get the fans to cooperate appropriately. But as you're doing different tasks, different things will load the CPU differently from how they're loading the GPU. So sometimes the CPU is hot, sometimes the GPU is hot. So there's actually a heat pipe that runs between the two of them. So then it says, oh, okay, right now the CPU is running hard, GPU isn't. I'm going to take that heat that was at this GPU and send it all to the CPU or vice versa. So it's actually extremely complex what happened here. And each of these fans, like if you were just your average computer, say you're running a desktop computer, those are most likely going to be off-the-shelf fans that some company produces. You say, okay, we need a fan. We're going to shove it in our device. That is not what we did here. Everything here is custom-made fans, custom-made everything in order for it to be, like I said, as small and elegant as possible so it fades to the background. Now, another example here as we kind of think through this. So say I'm using this device. This is a super sticky table, so it's not the best example here. But and all of a sudden I say, oh, okay, I want to go from doing, writing up my Word document, whatever I'm doing, and now I say, oh, I want to start editing this. And I pull out the pen and I want to start writing on it. Well, I want to effortlessly lower this and bring it to me. But it's a little bit further away than I want it to be. So realistically, what you do is you grab it and you pull it forward. And when you pull it forward, one of the risks you have is this power cable can come unplugged, and then you've lost everything you're working on. All that hard work you're putting into your Word document, gone. So these are the type of details that actually end up taking a lot of time. And when you're using a product, everybody uses products. There's some products you buy and you say, this is an incredible product. And then there are other products you buy and you say, this just you maybe can't put your finger on it. You say, this is not the product that I want to be using. And this is an example of that, where we put a special lock mechanism in there that you don't ever see. You can't, you could do something with snaps or something that looks funny. That's not what you did. You can come look at it later. All you do is if you pull on the cable, it won't come out. If you pull on that stress relief right there, then it will come out. And there's a really tricky mechanism in there to do that, actually. So I'm not going to spend too much time on how that works in interest of time, but we can talk more about it. Now, also, getting this monitor as thin as it is super difficult. So this is the thinnest LCD that is on the market anywhere, which has its own complications, which I won't go into too much. But along with that, we also have a 5 megapixel camera. You have power and volume buttons. You have all of the antennas up top. You also have microphones and speakers. So there's a lot that has to go into that. Now, the other thing, as you look at this, you see how thin it is, and you say, okay, so we want, like it sort of showed in that video, we want to turn your desktop into a studio, a drafting board. So you put it down, and you look at this, and I say, okay, what's going to happen if I start, if I come up to this, and I'm just kind of, talking to you, like, oh, hey, how's it going? And then you kind of lean on it pretty hard. What do you think is going to happen with something that's the thinnest LCD that is on the market? That was a huge concern for ours, because if you spend $3,000 on a device and then you lean on it and you snap the thing, that's not a good product. So what had to happen is we ended up taking, so this is an aluminum back cover that we have here. And aluminum by itself isn't that strong. So you have to put in special, kind of look like angel wings, but those are steel. And in order to get them in there to fit appropriately, those are actually glued into place. And then there's plastic around the edge all over here, which ends up kind of closing the beam, so to say, and then also allows the display to be bonded on top of it. So the thing that's important to note here is, I think the people that when you think about products, the ones that get the headlines, like, oh, the design engineers, blah blah blah. Maybe they actually don't get the headlines, but they certainly get the headlines more than a manufacturing engineer does, I would say. But on this product, and specifically in this area, you look at the manufacturing steps involved here. It's like you take this raw piece of aluminum, you have to stamp it, and then you do forging, and then you take a CNC and cut through it, and then you end up having to take and stamp these individual steel pieces, and then you glue them in, and then you put these plastic pieces in, and then you paint it, and you can see there's step, step, step. They just keep going. And from a manufacturing perspective, that's extremely difficult. So having engineers that are very good at manufacturing, absolutely critical. This product doesn't exist if you don't have good manufacturing engineers. So this is personally my favorite part because I'm a mechanical engineer background. And by the way, everything we've looked at is mechanical engineering and mechanical engineers that are working on this. But this in particular is like classic mechanical engineers, linkages and springs and everything, which is super exciting for me. So this, although this is a thin display here, it does weigh 13 pounds. So it's not heavy. I mean, it's not light, sorry. But our vision the whole time was that, you get home from work, your 5-year-old's there, you've been working, like you want your 5-year-old to run up to whatever you're working on, you want them to be able to paint, you want them to be able to mess around, you want them to be able to grab it and move it effortlessly. It's just one hand. And our CVP of all of this actually has a little kid, and that was always his thing. He's like, my little kid's going to try this, and if they have any difficulty, we're not shipping it. And it definitely builds some pressure that makes everybody feel like they need to do a good job. So in order to do this, I'll show a little bit more about what that actually takes here. So this is actually where this all starts. Do you think about making a product? You say, how are you going to do this? How do you know that what you're building is the right experience? Because you look at it now and you say, well, of course that's what it would look like. That's how it would feel. But in reality, when you're thinking about it, you say, I want this. We know for sure we want people to be able to write on this like a drafting table. And we know for sure that we want people to be able to use it like it's a regular desktop computer. And it should be effortless to move between them. But what does that practically look like? And how do you design an experience at the same time that you're designing a mechanism to build it? And that this sort of contraption we made here, it was just a table that we took. We had all kinds of weird counterbalance things just to say, this isn't how the product is going to work, but this is the way that we're going to build that experience to say, yes, this is exactly what we need to have our experience be. Now, when you're building a tablet, there are other tablets in the world. You can use a tablet and say, this is what I want it to be. When you're building a new device category, you can't do that. So you have to come up with unique ways to end up accomplishing these things. Now, the other thing that we had to do is when you're using this, I'm browsing the web and doing whatever it is I'm doing, and I say, oh, okay, well, it's a touch screen, right? I want to be able to touch the screen. I want to be able to write on the screen. I want to be able to do everything on this screen and not have it move. I also certainly don't want it to end up moving up on its own. So it's a really difficult needle to thread appropriately of how to do that. And in order for us to understand how much is somebody really, how much friction do we need to have here? How hard should I be able to push on it before it starts moving when I'm touching the screen? That's where we did a ton of user studies, and that's what this sort of scatter plot is right here, is saying, okay, we brought all these users in, say, just do all these different things. Let's see what angle you like to use that. Let's see how hard it is you write on here, because you want to get it just right so everybody can do what they want to do and not think about it. You don't want to be thinking, oh, I'm writing on this and it's about to slip. That's the last thing you want to think about when you're using a product. So that's where we ended up coming to the way the system's actually designed. So first of all, you have a 13-pound monitor, like I said. You need to make sure that's effortless. So how do we do that? Now, the first thing we do is you have springs here, right? So you have springs right here in the base. So those springs are basically, it's like a kind of an engine in a car. They're on a cam. So it ends up providing the force it needs to do to offset the force that gravity has. Now, to make things a little bit more complicated then, we couldn't get enough spring force down there. And to make things even more complicated, springs can only do so much work. And then over time, they end up degrading. Specifically, if they're in a higher temperature environment with certain types of springs. We didn't know this when we were doing this until we started finding that we were using these and doing tests. And all of a sudden we found, come in the next day, you go, oh shoot, my device just fell down. And why did that happen? So we had to end up taking and adding a spring up top here as well in order to take stress off of those in order to ensure that your device can behave consistently and not ever have the issue where it's falling down. Now, even more complexity here is you know that this is heavy, and you know it needs to come, it needs to be effortless as it comes up. Now, the problem is once you get to the top, this center of gravity on this actually goes right, kind of goes over the top of the hill. And this one, since it's cut out, isn't fully representative. So you can see what this one does a little bit is it snaps. Snaps to the front because all of those springs are saying, I need torque, I need torque, I need torque. And it goes, oh, shoot, I have too much torque. So what this spring does here is it actually is fighting the other springs the whole time and begins engaging at just the right time so that when it comes to the top, you can see it on this one, it's a consistent feeling for the entire range of motion. Now, to add even a little bit more to all of this, in order to have this, as you can see, every time I change the angle of this arm, I also change the angle of the display. And to get those to match and to have that end up being weightless, there's this, it's technically a 5-bar linkage, which we can argue about that if you guys want to, because people disagree, but a 5-bar linkage in there that that ends up controlling all of it. Now, the thing that also gets difficult here is you have manufacturing tolerances. And that's where, like this, well, actually, I'll stay on this one. Each monitor you build weighs a little bit of a different amount. And each spring you make has a little bit different spring rate. And each one of these links you make has is a little bit different length. And everything, there's variation everywhere. So how do you build these consistently? Well, I'll tell you the first build that we had, you'd have some where those links weren't tight, and you'd have others where this thing would just fall down on its own because the monitor was heavier than another one. So we actually go through and you do 11 individual adjustments at the manufacturing line to account for everything that's different. So these springs end up being adjusted. So you turn a nut on the end of this to get it just right and measure the torque. You do that on these top springs. You do these on these links in order for everything to be perfect. Does it take an incredible amount of time and energy and cost and trips to China and to Taiwan and every place else you could imagine? Absolutely. But that's the motivation for Surface with what we're building, is to make perfection and for people to be able to see the power of Windows and light up what Microsoft can do. Now, this can be a big Microsoft, big lets everybody cheer and say how great it is. But in reality, I think the other thing that's important to note here is this isn't about Microsoft. This is about what engineering can do in different aspects of your life that you don't see. And you should think about that when you're going and trying to figure out what you want to do. It's like, I love computers, or I love whatever it is. It's like, go make it and make it perfect. Because that everybody, like when people are using better products, they're happy. They like it, right? And by making a good product, it's really an incredible way that you can impart all of the training that you have in a way that pushes things forward. Now, I love the energy conservation stuff, and in some ways I say, man, that's far more noble than what I'm doing. But whatever it is, if you're passionate about it, just like jump in and do it. And I think that's one of the biggest things to take away here. We had a super passionate team that just kept working and driving and driving and driving for perfection. And you can see it shows up in a video like that.